Alrighty, now we're going to use the distance formula with some of these problems. Let's find the distance. So we're now going to find the distance between the pair of points. Round your answers to the nearest tenth if needed. So we're going to find distance. That's the distance formula. Distance is the square root x2 minus x1, second x minus first x, square that difference, plus second value of second y minus the value of the first y, square that difference. So negative 5, that is my first x. Notice I didn't highlight the negative because that's part of the formula. Negative 8 is the first y. Negative 6 is the second x. And 4 is the second y. Like I said, I like to use colors because now it's just plugging into my colors. So the distance is the square root of blue, negative 6, minus yellow, minus negative 5 squared, plus magenta 4 minus green, negative 8, and square. Now, what the biggest mistake students make with both midpoint and distance formula is not plugging in correctly. So I'm just going to double check that I have blue, yellow, magenta, green. So that looks good. Now, remember, nobody says minus a negative. Minus a negative is really plus. So minus negatives are really pluses. So the distance between these two endpoints is going to be negative 6 plus 5. And what's really kind of cool is in our calculators and in Desmos, you can just do minus a negative. Instead of changing it to a plus 5, you can do minus a negative in your calculator, and that doesn't make any, never mind. Alrighty, so now we've got negative 6 plus 5. That's going to be negative 1, and I'm going to square that. 4 plus 8 is 12, and I am going to square that. When you are plugging this into your calculator or Desmos, you have to use the parentheses. If you do this, that does not equal this. Negative 1 squared is negative 1. Negative 1 squared is 1. This one says square the negative. This one says square 1, make your answer negative. So this is going to be 1 plus 144. I don't know why I have two equal signs there. So the distance is going to be the square root of 145. In my calculator, the square root of 145 is 12.04159 458, but my answer doesn't want me to give all of those. My answer wants to be rounded to the nearest tenth, rounded to the nearest tenth if necessary. So this, the 0, is the nearest tenth. So my question is the distance 12.0, or is the 4 big enough to make it 12.1? Well, to make it 12.1, the next digit over would have to be a 5 or more. So this is going to stay 12.0 as my distance, and that'll be the distance rounded to the nearest tenth. All right, let's find the distance between these each pair of points. Find distance. Round to the nearest tenth if necessary. So the distance formula is the square root of second x minus first x, square that difference, plus second y minus first y, square that difference. Let's get some colors on here because colors make everything better in my opinion. So that's my first x, first y. Second x, that's x2, second y. Let's make this a little better. There you go. Alrighty, so let's go ahead and estimate the distance between these 2 points. Let's find that distance rounded to the nearest tenth. So parentheses, because I'm going to have to make sure, if it's negative, I'm going to square it. So blue is negative 7 minus, this minus comes from right there, minus yellow. And I'm going to square that. plus magenta, -8 minus, this negative comes from the formula, minus green, -5. Let's square it. Now what's super nice is you can just take this formula right here and plug it into your calculator or the Desmos app, and it's going to simplify it for you. I'm going to do it out by hand though. So -7 minus a negative becomes a plus. -8 minus a negative again becomes a plus. I'm going to square that. So -7 plus 5, that's -2. It's in parentheses. When you square this, it always wants to be positive. That's why it's in parentheses. And a -3, and we're going to square that. So this gives me a distance of 4 plus 9, and that is the square root of 13. So I do need to go ahead and round that to the nearest tenth. My calculator says 3.605. Okay, now the nearest tenth is the 6. So does it stay 3/6, or is it big enough to become 3.7? Well, we can ignore this 5. So you ask, is the 0 big enough to make it a 7? And it is not. So we're going to stay 3.6. Rounding matters. If you do not round correctly, you will get marked as wrong. Alrighty, so go ahead, complete problems 15, 16, 17, 18. Hit pause. When you're done, come back and we'll finish up our distance problems. Alrighty, welcome back. So let's find the distance between these two endpoints. Now notice this time I'm giving you a segment, but honestly, who cares that it's on a segment? Because this segment has endpoints, which is where we're going to get our information from. For instance, this point right here, it's at -5. 1, 2, 3, 4. It's at -5, +5, because I counted left. 1, 2, 3, 4, 5 on the x-axis. 5 left, 5 up. This point right here is 1, 2, 3 right. That's a +3. And then 1, 2 down, -2. So when I do the distance formula, we're going to do x2 minus x1. I always like to start off by writing my formula so I can color it up and go from there. All right, so let's get some highlighters in here. So first x value, first y value, x1, y1, x2, y2. Okay, so let's plug in. Distance equals the square root of, parentheses, blue, 3 minus yellow, minus -5. Square that. Plus magenta, -2 minus, comes from the formula, 3, and I'm going to square that. So the distance is, parentheses, 3 plus 5 squared plus -2 minus 3 squared. So we're going to take the square root. 8 squared plus -5 squared. So the distance is the square root of 64 plus 25. So this is the distance is the square root of 89. And the square root of 89 gives me about 9.4. It says 9.43. The 3 is not big enough to make it 9.5. So that's what it stays. Boom. All right, so go ahead and complete this assignment. I don't know if apparently we've been having some trouble with Student View. So if it's not available, I will give you time to enter that in. We may take an entire class day just to enter answers into Student View. Alrighty, everybody. I hope that that made a lot of sense, and I will see you when I see you.